Hello and welcome to the third section of your self-paced unit for Unit 8. This is going to be zero exponents and it's going to be the quotient rule. So make sure that you have everything ready to go and I'll meet you on the next page. Let's take a look at our to-do list for 823. You are going to be watching your video. Both of the lessons are included in one video. You're going to be taking notes by either downloading the note template or by using your classwork notebook. In the notes, you need to make sure you define what each of the rules are, so there should be two sections. You need to have some examples that you find from our work together, and then we would like you to create a problem of your own to prove your understanding of the two rules. There will be a learning extension that will be linked to the group document that you copy, and then there'll be some R&P to do some additional practice. After all that's done, you will have a formative and then a summative. Please make sure that you come to me right here, so right after the learning extension, in order to get the R&P with all of this information ready to go. All right, thank you. Our learning targets have remained the same. They are the ones in black. Our new one is that I can apply the rule of zero to exponents. Before we begin, it's important to make sure that we keep our knowledge with us as we move from section to section. So what I'd like you to do is pause the video and prove each one of these scientific notations are correct or incorrect. And then please join me when you are ready. Welcome back. So the very first problem asks you if this is written in scientific notation correctly. Is this correct? The decimal is after the first non-zero number. There is a multiplication, a times 10, and an exponent. So is this correct? Yes, this is correct. Taking a look at the second one, you can notice that the decimal is not after the first non-zero number, so we're going to move it 1, 2, and 3 times. When we move in this direction, this is a negative direction, so we're going to be subtracting 3 from our current exponent. Rewriting this, so we are going to be rewriting this like I just said, and we will have 8.9, because those are our non-zero numbers, times 10, and then 8 minus 3 is going to be to the power of 5. And our last one, again, you can see our decimal is here, which is not after the last non-zero number. So we are going to move that 1 2 times, and this is a plus 2 because we're moving it to the left. We do not have a multiplication symbol, and instead of the 1, we want a 10. So we'll have plus 2. So we'll rewrite this whole thing so it's correct. 3.219 times 10 to the power of 2. Hopefully you did okay on that. Moving on, the exponent 0, what does it mean? Take a look at this slide, and we're going to walk through it. So if we have 3 to the power 4, if we put that in the calculator, we would get 81. And then 3 to the power of 3, we would get 27. Well, let's take a look at these two numbers. So we subtracted an exponent, right, to get here. Now, let's think about our opposites, right? This gets us to 81 by 3 times 3 times 3 times 3. And that's 4 times. Now, we subtracted. So what is the opposite of subtraction as far as in the multiplication world? It would be division. So if we would take this and we would divide it by one of the 3's that we're removing to get from here to here, we end up getting rid of both of those, and we have 3 times 3 times 3, which is 27. So again, if we do this idea of subtraction, divide by 3, get rid of one of those, we have 3 times 3, which of course is 9. So now this next one, we're subtracting, so we're going to have 3 to the power of 1, right? We're going to divide, which is just going to give us 3. So now let's think about this. We are going to have 3 to the power of this, right? If we're continuing to subtract. And what do I have left? I have 3. So I'm going to have 3, and I'm dividing that by 3. And what does that equal? That equals 1. So 3 to the power of 0 is equal to 1. What does it mean? We'll think about that for a second. What does that mean? What that means is that any number to the power of 0 is always 1 when you think about the power of division and undoing. So x to the power of 0, that's going to equal 1 also. Everything to the power of 1 is equal to 0. And if you think about the variable x, that it could be anything, it could be any number. That's why we say we always know it's equal to the value of 1. Let's take a peek at all of these problems. We just did 3 to the power of 0, so we know that that's 1. Again, any number to the power of 0 is 1. Any number to the power of 0 is 1. X to the power of 0 is 1. This is our value. Negative 8 to the power of 0 is 1. We're going to take a look at this one right here. What do we actually have here? We actually have negative 1 times 3 to the power of 0. The only thing that's raised to the power of 0 is the 3. Versus here, we have our parentheses to show that everything is raised to the power of 0. So we have negative 1, 3 to the power of 0 is 1. That equals negative 1. Be careful with a problem like this. We love those kinds of problems. So of course it's really not that simple, right? What we're going to end up doing is combining all of our rules so that we really make sure we have that understanding of how to use them all in conjunction with each other. So let's take a look at this practice, all right? So if we take a look, what do we have? We have this and we have this. From my previous videos, you see that I have combined things in the idea of combining like terms and then solve them individually. I'm going to keep doing that. So I'm going to combine my x's together. X to the power of 3, x to the power of 5, and then I have 2 to the power of 0. This, ladies and gentlemen, is the product rule, and this is the rule of 0. Just so you understand what they are. The product rule states we keep the base and we add the exponents. And then 2 to the power of 0 is 1. So the solution to this would be x to the power of 8. So let's take a look at this one. Again, what I do is I simplify inside the parentheses because that's what order of operations tells us to do. So I'm going to just erase that. I'm going to take my numbers first. So I'm going to have this, all of this together to the power of 4. So I'm going to have negative 2 times negative 4. Okay? And then I'm going to take my x's. Oh, but before I do that, what do I have here? I have x to the power of 0. That's 1, isn't it? Okay. So I really just have x to the power of 3, and that's 1. So I'm not going to include that in anything. And then I have y to the power of 7. Are we okay with that? You could make that like that even if you wanted to. Okay, so I have negative times negative, which is going to give me a positive 8. And then I have x to the power of 3, and then y to the power of 7. And that's all to the power of 4. So I have 8 to the power of 4, I have x to the power of 3 to the power of 4, and I have y to the power of 7 to the power of 4. So the answer to this is going to be 8 to the power of 4, x to the power of 12, and then y to the power of 28. Let's take a peek at this problem and break it down just like we did the last couple of problems. I'm going to incorporate these and then these. I'm going to have 2 times 3, and then I'm going to have x to the power of 3 times x to the power of negative 3. 2 times 3 is 6. And then I have keep the base, add the exponents. So I have 6 times 1. My answer is 6. All right, moving on. What I would like you to do is pause this video, work on these problems, and then meet me back here. Well, welcome back. So if we wanted to simplify this, I would have 7 to the power of 5. I'm just going to go ahead and write the answer, and then x to the power of 10, because you're taking this and you are distributing. For these, I'm going to combine these two and then these two. I have 8 times 2, which is 16. Keep the base, add the exponents. Product rule. And this is the power rule. This is our 0 rule. Anything to the power of 0 is 1. Easy peasy, right? So this is going to end up being two things, right? The first thing we're going to do, the first thing is the product rule. And then the second thing is the power rule. So let's do the product rule first. I'm going to combine these first. I'm going to have 2 times 4. And then I'm going to have x to the power of 6, x to the power of 4, and all of that is to the power of 4. So I'm going to simplify first. I'm going to end up with 8, and then x to the power of 10, and that's all to the power of 4. Now I'm going to apply the power rule. So I'm going to distribute. I'm going to have 8 to the power of 4 and x to the power of 40. All right, moving on. This is also a power rule and a product rule. So the first thing I'm going to do is combine anything that is a like term. Let me erase that for a sec. Okay, so the first thing I have is my numbers. So I'm going to have 2. Do a little check mark to make sure I got it. I only have one a, so I'm going to have a to the power of 3. Got rid of that. So now I'm going to do my b's. I'm going to have b to the power of 3 times b to the power of 3. And then I have c to the power of 1 and c to the power of 3. And that is all cubed. All right, so let's see if we can simplify this a little bit. I'll try to squeeze it in here. I have 2, a to the power of 3, b to the power of 3 plus 3 is 6, and c to the power of 4, all raised to the power of 3. So now I'm going to distribute. So I have 2 cubed, a to the power of 9, b to the power of 18, and c to the power of 12. You could obviously do 2 cubed as 8 if you would like, but it's not necessary. Hopefully you did okay on these, and we are going to move on. This is just a really nice screenshot of what we've done so far with some examples. If you would like to take a screenshot of this and add this to a notes section or even add it to your notes for further use, I think that would be a really good idea. All right, let's move on to the quotient rule. This is our second part of this lesson. Make sure you have your notebook out. Our new learning target, I can apply the rule of exponents using the quotient rule. So here is our rule. Of course, when I did these all ended up in a bad spot. I'm sorry. The quotient, it's an answer to a division problem, right? So we're going to be doing some division. The quotient rule. For like bases, you subtract the exponent from the numerator. This is important, to the denominator, and then you simplify. So how does it work? Let's give it a try. So like bases, you subtract the numerator from the denominator. 5 to the power of 1 equals 5. Easy, right? Let's do it again. Like bases, subtract your exponents. 4 to the power of 7. That's your answer. Let's do it again. Like bases, subtract your exponents. All right, let's break it down. Now, with a problem like this, I often do this to show the division between the two sets of problems. So I have 2 problems here. I have 2 divided by 4, and then I have x to the power of 6, x to the power of 4. This becomes 1/2. This becomes x to the power of 6 minus 4. This becomes 1/2 times x to the power of 2. And then you have to put it back together. X squared times 1 is x squared all over 2. Let's try a few more. This is, the first one is obviously the product rule. This is our product rule. Just set up a little differently. So we'll put them together. I have 4 times 5. And then I have x squared times x squared. 4 times 5 is 20. Keep the base, add the exponents. This is going to be the power rule first, and then the quotient. I need to distribute first, right? So that's going to be x to the power of 3, y to the power of 3, all over x, y to the power of 3. I'm going to do this. Probably should have used a different color. Let me go to here. I'm going to separate them. And now I'm going to write up my two problems. I have two quotient problems. I have x to the power of 3 minus 1, and I have y to the power of 3 minus 3. So now I have x squared, and I have y to the power of 0. So I have x squared times 1. My answer is x squared. All right, let's move on to our last problem. Again, I'm going to put a little spacer in here just so that everyone can see what I'm doing. So I'm going to write my problems out. I'm going to have I'm going to have a to the power of 5 minus 2, because that's my quotient rule, times c to the power of 11 minus 3. So I have a to the power of 3 times c to the power of 8, and I'm going to just put those together. They both stay on the top. A to the power of 3, c to the power of 8. All right, hopefully you did okay with that. Let's move on. All right, this is your last page in this lesson. You can stay with me and we can go through everything together, or you can try them and then come back. Completely up to you. So this first rule, this first one up here is going to be first the product, and then this is going to be the power rule after that. All right, so the first thing I'm going to do is combine. So I'm going to have 2 times 5, and then I'm going to have x times x to the power of 3, and all of that goes to the power of 4 once I'm done simplifying. So now I have 10 x to the power of 4 to the power of 4. So my answer to this problem is going to be 10 to the power of 4 x to the power of 16. All right, let's do it again. This one's super easy. This one adds the 0 rule. So 3 to the power of 0 is 1. X to the power of 0 is 1. This equals 1. Love those kinds of problems. All right, moving on. Now we're going to add our quotient. So the first thing I like to do is I put a divider in here and I set up my two individual problems. My first problem is going to be 5 over 15. My second problem is going to be x to the power of 8 minus 3. That's the quotient rule. 5 over 15 is 1 over 3. And then this becomes x to the power of 5. I put them together. 1 times x to the power of 5 is x to the power of 5 over 3. That's your answer. All right, let's do our last problem. Again, I'm going to put my little divider in here. So I'm going to have negative 12 over 3, keep track of your negatives, times x to the power of 6 minus a minus 7. All right, let's take care of this one first. Negative 12 divided by 3 is negative 4. This becomes, let's write it down over here, x to the power of 6 plus 7. Watch your negatives. Okay. So I have negative 4 times x to the power of 6 plus 7 is 13. All right. Hopefully this worked for you. Please make sure you're writing all of it down and move on to the next item in your checklist.